Hello, in this video I'm going to be showing you how to calculate the determinant of a 3x3 matrix. Now I'll be timestamping each part of the video below so you can just skip through to whichever part you want to see, whether it be a worked example at the end or just the formula to find the determinant. And if it is useful, then please do like and subscribe and go over to my channel for tons more maths tutorials. Let's take a look then how we can calculate the determinant of a 3x3 matrix. So you can see in this red box here I've given us a 3x3 matrix M. And I've also written down a formula to find the determinant of M. It's this thing here. Now, I really wouldn't bother remembering this exact formula, okay, for two reasons. One, it's quite long, and so it's just kind of a waste of time to try and remember that. I would instead learn where this comes from, which I'll show you in a second. And also there are alternative ways of finding it that might be better depending on the matrix you're using, okay, and we'll take a look at that later on as well. So the first thing I'm going to do is introduce another 3x3 matrix, okay, which is just going to be a matrix of signs. So it's just alternating pluses and minuses like so. Okay, so this isn't very tricky to remember. What this does is it gives each element in M a different sign. So for example, element A will be a positive sign, whereas element B will be a negative sign, and so on. Hopefully you get the point. Now, all we need to do to find the determinant of M is pick any row or column we like. For the sake of this, I'm just going to pick the first row. And we start off with the first element in that first row. So for example, element A. I then say, okay, is it positive or negative? So let me look at the sign. It's positive, and so that's why I have a positive A here. I'm then going to eliminate the rows and the columns, okay, of element A. And you can see I'm left with this 2x2 matrix here. I'm then going to find the determinant of that and multiply it by A. We're then going to move on, so let me move on to the second element. So element B, which is this one. I then look at the sign. Well, it's a negative sign, so that's where that negative B is coming from. I then eliminate the rows and the columns of B, and you can see I'm left with this 2x2 matrix here. I then find the determinant of that and multiply it by negative B. And you can probably guess where the final part is coming from. I look at the final element in that row, so element C. It's positive, so plus C. I then eliminate the rows and columns of C, and you can see I'm left with this 2x2 matrix. I then find the determinant of that and multiply it by C. Now we could find an alternative formula by picking a different row or a different column, and I'll show you an example of that later on. So let's take a look at how we can actually find the determinant. So here's my matrix M, and I'm going to first, just to make it really clear what's going on, write down my matrix of signs like so. Okay, and I'm going to use the first row to find the determinant. So I can say, okay, the determinant of this matrix M is equal to, well, remember we're using the first row, so I'm going to use the first element in the first row. So 1, is it plus or minus? It's plus, so we're looking at plus 1. I'm then going to eliminate the rows and the columns of that first element, and you can see I'm left with this 2x2 matrix. So I'm going to multiply by 1 by the determinant of this matrix like so. Okay, let's move on to the next one. So let me get rid of the highlights. The second element is 1, okay, and it's got a negative sign with it, so minus 1. Let's then eliminate the rows and columns, and you can see I'm left with this 2x2 matrix, 0, 4, 0, 2. So I find the determinant of that. We then move on to the final element, which is 6, which is positive. So plus 6 multiplied by, well, let's find the remaining matrix, so get rid of the rows and the columns. And you can see I get a 2x2 matrix, 0, 1, 0, 8. There we go. So let's calculate it. So the first one, I've got 1 multiplied by, well, the determinant is going to be 1 multiplied by 2, subtract 4 multiplied by 8. The next part, I've got minus 1 multiplied by 0 multiplied by 2 is 0, subtract 4 multiplied by 0 is also 0. And finally, 6 multiplied by 0 times 8 is 0. Subtract 1 multiplied by 0 is 0. So these just go to 0, and we're left with negative 30 as our determinant. So let's see an alternative way that we could calculate this that might be better for this given matrix. So we've got the same matrix again, and in fact let me bring down my matrix of signs. Okay, and this time I'm going to pick the first column, okay, and you'll see how this is going to work. So the determinant of M is going to be equal to, well, I'm using the first column, so the first element is 1, and it's plus 1. I then am going to eliminate the rows and the columns of that one, so I'm going to find the determinant of 1, 4, 8, 2. Okay, this is why this one's going to be useful. So now the second element is 0. It's minus 0. Well, there is really no point in finding the determinant of this matrix here. So it would be 4, 6, 8, 2. Why is there no point? Well, because I'm multiplying it by 0. So this whole thing is going to go to 0. Okay, so this is why this column might be better for finding the determinant than the first row. Let's move on to the final element, which is also a 0. So it's plus 0. And again, I don't need to find the determinant of that final bit because, well, I'm multiplying it by 0, so it's just going to go to 0. So the determinant of m is equal to 1 multiplied by 2 subtract 32. And so you can see I've got negative 30. Hopefully this was useful. If it was, please do like and subscribe and go over to my channel for tons more maths tutorials. Thanks for watching.